Hey guys, in this video I will explain you how does Ethereum work. If you don't know who I am yet, I am Amaury Amapakabo, CEO and co-founder at Blockledge. This is a course that is extracted from our education platform Blockledge, and if you want to see the full course you can find it at blockledge.xyz. The link will be in the description. So be ready to learn in this video. I hope you love it. If you do, don't hesitate to leave a like, a comment, and also subscribe to our channel. We have decided to provide you a variety of content on this channel, from courses to interviews and also other type of content that you'll see in the later stage of this channel. So you know what to do. All right, let's get into it. Hey guys, welcome in the second video of this introduction to Ethereum. So in this video, we're going to talk about how does Ethereum work? Because now that you know a little bit more about Ethereum, who created it and why, we need to actually understand how it works. First, we will see who runs the code. Secondly, we will see what is a smart contract. And lastly, we'll talk about gas fees on the Ethereum network. So you might know that already, but usually companies like Meta, Amazon, Uber, all of these big tech companies usually use what we call data centers to store data and also to store their software. And a data center actually just looks like the picture that you have on the screen right now. It's huge warehouses where there are thousands of servers working daily, day and night to serve data to every computers on the world. Although this is actually a pretty good system, servers are not really optimal because they are easy to hack. Basically, storing every server at one particular location on Earth makes it pretty easy to actually hack the place. Or if there's a major issue like a fire or a storm, the servers can easily be destroyed. So it's not really great. So as I just said, servers are more prone to failure or issues because they are located at one single place, which is basically a single point of failure. Also, servers are closed and uncollaborative by default. Companies like Meta, Amazon, Uber, or Netflix want their data to be very protective because that's basically how they make money. They gather data on users that they use to serve better services and products. So for example, Netflix, they know a lot on you, and that helps them give you more better quality shows that are relevant to you. And that's why, because they have this algorithm that they wrote to gather data on you, they want the data to be as secure as possible, and they don't open this data to anybody. It's very, very private. And the last thing that makes servers not very optimal is that they are controlled by one entity. So that means basically Meta can use your data as they want to because they are the only one to own this data, and you can't actually know what data they hold on you, which is a little bit problematic. And we had a lot of discussions back and forth about this topic. Even the CEO, Mark Zuckerberg, really went to court for that. And one thing that makes blockchain and Ethereum specifically in this course great is that they are actually open and decentralized. So instead of running on one single computer or server, Ethereum is basically running on every computer that wants to participate in making it work. This sentence sounds a little bit confusing, but basically it means that every computer that participates in running the Ethereum network is adding to the huge Ethereum computer that already exists. To make it even easier for you, it basically means that Ethereum is a huge computer and that each computers just add to the power of this huge computer. And actually, Ethereum's network is called EVM, and that stands for Ethereum Virtual Machine. We've talked about this in the first video. Basically, this is the name that we gave to the whole network, and it is pretty comparable to a huge computer that runs the whole blockchain itself. And this way of operating makes it way better and open than servers. It makes the network completely decentralized. So that means that not one entity is running the code and gathering data, but it's really an open world that everybody can participate in. It's also securing the network against hacks. Why, you might ask? Well, that's because in order to hack Ethereum, a hacker would need to hack every computer on the blockchain, which is almost impossible when you think about it. There are thousands and thousands of networks out there, and in order to hack all of these combined computers, the hacker would need computational power, which we can't actually produce right now. Maybe one day it will be the case, but right now, this doesn't. It's just almost impossible. The third thing that makes this network great is that it's actually globalizing the network as well. It doesn't sit at one particular location on Earth, which removes any kind of problems related to weather, for example, to storms, fires, or politics as well. Because I can run my little Ethereum node from here, and you can do it as well. We are sure that we don't sit at one location, and for example, if a hacker tries to hack me and actually does it, it's not gonna have any impact on the network. Also, no authority, government, or corporation can control the network or shut it down. And this is great because we live in a world now where people are trying to be more decentralized, more open, trying to transact without the need for a third party. And Ethereum really helps with this because nobody can shut it down. Nobody can, remove it or cancel it. It's not possible. Ethereum is limitless and it lives on the internet and nobody can ever take it back. Lastly, this system of globalizing and decentralizing the whole network is making the network down-proof. Because it runs on hundreds of computers, Ethereum cannot be down, as every computer in the network would have to be down for it to happen. So once again, we can go back to this hack thing. Because the big computer that is Ethereum is running thanks to thousands of computers, it makes it almost impossible to be down. Because if my little computer is down and Ethereum is not working on my computer anymore, it's not gonna have an impact on the rest of the network. The network is still gonna be able to transact, is still gonna be able to use Ethereum just because there are thousands of other computers that make sure that this network is running at all times. So really, when you get the bulk of all of these, it makes Ethereum a very robust network. So in short, everybody can help running the Ethereum network. It was built as a peer-to-peer network, which means that no definite entity runs it, but collaboration between humans does. So this is great. That means that real collaboration with real people can create something as big as Ethereum, and that is great. Now, I've talked to you about applications and dApps, and you might be wondering what it is. Well, a dApp basically runs with what we call a smart contract. So if you remember well, we said earlier that Ethereum was comparable to an iPhone. Essentially, what we call a dApp, decentralized application, is run by what we call a smart contract. A simple metaphor for a smart contract is a vending machine. It is basically a machine that with certain inputs gives you a certain output. So if you want a little Coke at the middle of the machine, you would have to click on button 8, then give the machine $1, validate, and here you go. Your Coke is going to be yours. Essentially, a smart contract is exactly the same thing. A specific input guarantees a specific predetermined output. In short, a smart contract is simply a program that runs on the Ethereum network. And now you might be wondering how. Well, That's because they have these particularities. They are a type of account on the Ethereum network. We've said that earlier in the first video, in this first chapter of this course. There are two types of accounts on the Ethereum network. There are user accounts and contracts. So contracts are a type of account, and that means that they have their own address, they have a balance, and users can send transactions to them. It basically means that you could have a smart contract and you could send it money, and the smart contract would hold this money that you sent it because it has a balance, but it's not controlled by anybody, it's controlled by code. So that means if the smart contract says that all of this money should be given back to the creator, well, the creator of the smart contract could say and could write this in the smart contract. 100% of the funds that this smart contract holds is sent back to me, for example. But it could be something different. Maybe the smart contract says that 50% of the balance is going to be sent back to the users. And when you start thinking about all of these possibilities, you realize that it's really endless what we can do with smart contracts. We can do a lot of disruptive systems that would simplify human interactions in general. Smart contracts are not controlled by users. Instead, they are deployed to the network and run as a program. So as I just told you, that means that nobody can come and say, yeah, this is my balance, talking about a smart contract balance. The only way you can get the balance out of a smart contract is if there's a line that says that this balance is going to be sent back to someone with a certain input. So really, you gotta see the smart contract as a vending machine once again. So it's just a thing. It's a little program that you write. You put it on the Ethereum network, and then it just does what you said it would do. That's just like a vending machine. So if you put your little dollar and you click on 8, you're gonna get your Coke. That's the same with smart contracts. If a user, for example, sends this amount, that's this type of transaction, it's gonna have this type of results. That's a program. It's not someone deciding whether this should happen or not. It's just the program checking whether it is possible, whether the input correlates so that the output can happen. So as I just explained, smart contracts can define rules like a regular contract and automatically enforce them via code. In the physical world, we rely on contracts right now to interact with each other, to install trust. But there's a big flaw about the system, which is that humans are not completely neutral. So that means that if ever you write a contract with someone, the only thing that protects you is law. But even law has some flaws. And for example, you could definitely be right, but still, because humans make mistakes, you could lose the trial if ever you go there. But with smart contracts, it's simply impossible to not enforce the contract because it is code and nobody can change this code. Nobody can pretend that this was not in the contract. That's great. Contracts cannot be deleted and interactions with them are irreversible. Anyone can write a smart contract and deploy it to the network. All that is required is enough ETH to pay for the gas fees. Basically, that's a little fee that the Ethereum network requires to make any type of transactions and also to deploy smart contract to it. So I just mentioned gas fees. So what is gas? It sounds confusing. It sounds like a weird, dark concept, but it's pretty simple to understand. Gas refers to the unit that measures the amount of computational effort required to execute specific transactions on the Ethereum network. Each transaction on the Ethereum network needs gas to complete. Gas fees are paid in Ethereum's native currency, which is Ether. Gas prices are denoted in GUI, which itself is a denomination of ETH. So as I just said, you need gas to deploy a contract to the Ethereum network. But in reality, every transaction on the network needs gas to complete. When paid, each gas fee is divided into two parts. One part is burned, which means that it's completely removed from the circulation, and that is called the base fee. And the other part goes to the validators of the network, which are called miners, and that's their reward for doing the work to run the network. Gas price is not fixed, as it depends on the transaction being sent to the network and also priority order of the transaction. You can pay more or less gas if you want your transaction to go through faster or slower, and that's called priority fee. And I want to show you exactly how you can do this with MetaMask. So here I am in my MetaMask account. I sent $20 to it just so I can show you gas fees. So basically, if I want to send crypto to someone, I click on send, and here I can send money to one of my addresses. It's actually the same address, so I'm not going to complete the transaction, but it's just to show you what gas fee is. So let's say I want to send $15 to this address, right? I click on next, and here you see I have what is called gas fee here. Estimated gas fee, which is 30 cents. It's not a lot. And if ever I want to go faster with this transaction, I can click on edit here. Then I can click on show recommendation here. And here I can choose low, medium, or high. And this is the priority order. So if I go on low, I'll pay less gas, as you can see here, but the transaction is going to go through slower. If I click on high, my gas increases and my transaction is going to go through faster. And if I click on medium, which is standard, my gas is also the same. It's 54 cents now, and my transaction is going to go through whenever it needs to go through. So now that I showed you that, and that you know a little bit more what gas is, you might be wondering, but why? Why does it exist? What does it do? Why do we need to pay that? Well, gas is actually extremely useful in Ethereum, because it helps securing the network even more by preventing any malicious or spammy smart contract to deploy on the network. For example, someone with bad intentions could deploy a smart contract on Ethereum that would be an infinite loop that would crash the whole blockchain. With gas, the address running the smart contract would eventually run out of ETH, and it will not be able to pay for gas anymore, which means that transactions will not go through anymore. So first of all, it actually helps securing the network even more. Also, for the network to be decentralized and run by validators and miners, we need to reward these people. And gas is actually sent to validators whenever a new block is created. That incentivizes people to actually become a validator on the network. So that's also a way to reward people who participate in this decentralized network. Great that you made it here. That was a very dense video in terms of information, so I really hope you took some notes. In the next video, we will cover Etherscan, which is the blockchain explorer of Ethereum, and we'll see all of these subjects. What is Etherscan? How to look up a transaction and wallet, how to look up smart contracts on Etherscan, and how to check gas prices on Etherscan. So once again, if you have any questions, let us know. Leave a comment below. Tell us what you think about this course. Feedback really helps us make better courses with better information, and also to get more and better experts. So do it. If you have any questions, you can also send me an email, and I'll see you in the next video. Bye. So guys, here we are. You made it to the end of this video. That's great. I hope you loved it. If you did, don't forget to leave a like, a comment, and also subscribe to our channel. This helps us a lot. Once again, if you want to see more of this course, go to the link in the description. There'll be a link to Blockledge.xyz, which is our education platform on blockchain. So I will see you in another video. Cheers!